Right. Good evening, everyone. Right. So first, welcome to your first session, CCNA Introduction to Networks. This is the first chapter that we're going to be doing. But before we get there, I think for those who haven't logged in my account yet, let's start by logging in. I'm going to log in into my account, the one I'm using, so that you can see how you're going to be browsing through the content, number one. Where do you get the labs? Number two, where do you get the simulation tool that we're going to be using, the packet tracer? Right. So as I log in, one thing to note, this is a very new platform, a very recent platform created for NetAcad. In a couple of changes, if you have done CCNA before, there wasn't that much pressure panye time, panye my exams. You could do that as you wish. You could even go through this course offline. This is a bit different. Ndakupa notes offline ari PDF file. You can browse through those, but that is not enough. Especially kana kusvika nyaya negotiate a discount, which is guaranteed. But if some of the things are not meant, for example, if you do not pass CCNA 3, Enterprise Networking Security and Automation, you are not guaranteed to getting that discount. If I already have Packet Trace installed, can I still keep it, or I will have to uninstall and download again? If you already have it installed, I think by now it's already outdated. You need to find which is the latest version, download that one and use it. Because previous versions, they can no longer open my files, my PKA files are very recent, right? So you need to check the version of the packet tracer on IO, then download the latest, because if not the latest, some of the labs will not be able to run on that. Right. So I was saying some of the things that you need to make sure you do to get the discount is to pass that CCNA 3 exam. On average, all your exams, on average, we had you need to have at least 70%. It sounds difficult, but it actually isn't. I think we work together to make sure we get plus 70%. Theory-wise is very easy. Maybe the skills assessment, those ones may become a bit more complex than the theory. Theory is very easy. But by my labs up, actually knowing what you are doing in theory, it will be very difficult. Right. So this is the typical content. Yamchawana pa packet tracer. As you go through everything that you go through, you will see in my percentages and showing you have gone through this content, you have gone through this video, you've gone through this lab, you have answered these questions. So for example, I can see from my left side, a video, there's a video in Mangwananga. I'm not going to browse through those. There's Iran's packet tracer. This is a lab, right? What do you do with the lab like this one? I think there's a file you have to download. If you go per lab, there are two options. One, you could download a lab file. The other one, you could download the PDF file in a lab. I think in the second session tomorrow, Dopa chat the sana with my labs, term chapter number 2. But just browsing through the content, you know, really browse to download it. We IDM pick that one. Right. So just browsing through the, if you browse, record with Panapata Franib. It's Cisco making sure you go through the content here so that you'll be able to get the discount. They need to know if they join an academy, they are actually doing it to study and going through the academy instead of getting my discounts. So it's either kana on Wi-Fi, if you are connected, band or repo, for those guys in Zimbabwe, you'd understand. You go through everything online. It's very easy. As not data as no go through everything online so that you get my percentages up at least 80%. Maybe you might skip 1 or 2 videos, but plus 80%, it means you're actually going through the content. So that's one. Kana wapedza going through the content, you see pane my exams, pane my questions anenge aripo in between. Let me see. Network affecting our lives, network components. Right. For example, this one. Check your understanding. These are some of the questions you'll be getting. It's very important to go through my questions because it gives you an idea. You could see how will the final exam be? Because final exam in CCNA is mainly theory. I think it's almost 90-something% theory, with a few questions with a lab, the final certification exam. So it's theory, in my answers, A, B, C, D. My single answer questions, my multiple answer questions. If you have gone through the content, this is the good thing about QCM. If you have an idea, questioning away my answers, it's very easy to eliminate my wrong answers. But this is wrong, this is wrong. I think this is the correct question. So one is going through the content, obviously, and understanding my concepts which will be pushed across. Two, knowing my questions, the type of questions is nowhere and how they are being asked. So it's very important going through my questions. I prefer you understand and know how to go through my questions and how to respond to my questions than going through 600 pages and then my questions, you go through them, then you go back and revise or use Google, ChatGPT, whatever it is, to check my answers. It's much better that way because my questions, the goal is to get certified. Of course, getting certified with enough knowledge and understanding is all with that will be my job. With enough understanding, simplifying my concepts, I'm not forgot they're a bit difficult. That will be my job. But your job is to get certified. Because if you get certified, then I'm also getting paid as well. So it's very important to me that everyone gets certified. All right. So my questions, go through my questions. So for this one, ndakatombe attempt 100%. If you don't get it correct, you redo, reset and redo, practice, always, always. So pangatotaura kuti you need at least an hour a day kuti zvinhu zvitifambire. Hour irororo, maybe 10-15 minutes, you're just going through the questions. If you're sharp enough, maybe just once, you're good to go. They are stuck in your head, my questions, my answers. But if you're like me, almost every day you go through some questions so that the brains are not active. It knows that I'm preparing for an exam. Right. Now, so you go through this, my percentage achikwira. So panel my exams to report, my check understanding. Then at the end of every chapter, every module, there are also questions and so for this one, there's another quiz, module quiz. Zero pressure. You can do that at your own time, right? No problem. Then after the chapter 1, 2, 3, there is this exam, checkpoint exam. For my timetables, 3 months. I think every Monday we are attempting an exam. Some of you are switching to 6 months. Okay, no problem. But let's try by all means. Easy. Things will be very easy. My first chapters, I think things will be very easy. So let's try. Next week, Monday, we cover chapter 1 to 3, to your exam Monday. Because if you're going to have at least 4 weeks, particularly one, we need to move. Kwekutanga uko kune zvinhu zviri a bit cheap kuitira kuti kana tasvika kuIPv for addressing, it will take us a lot of time kuti tinyatsonzwisisa zvinhu zviri kuitika. So kwekutanga kuintroduction, we are moving very quick. I think chapter 2 in a bit longer, we'll need some time because it has some labs. But going forward, we'll be moving very quick. Don't be worried about speed. We'll get there. Right, so Kantapeza, chapter 1 to 3, module exam, you attempt the module exam. I think 4, 5, 6, 7. There's another exam, a checkpoint exam. Every Monday, we try to attempt my checkpoint exams. Kantapeza, Jesse, we have my exams are work. My exams are they'll be opened Kana tapedza, then we will try to attempt those. Pane yatinoti skills assessment, which is a practical exam rinoitwa papacket tracer. Then there is the final exam rinoitwa theory wise, rine questions akaita kunge iwaya atitomboona papractice ari very simple. And kana tapedza, then we are done. CCNA 1 done. You get your certificate of completion. We move to CCNA 2. Right. My resources. No, these are not the resources I'm looking for. Right, for my resources, come on a packet tracer. If you are logged in, let me see. Explore. Okay, this is a new right, Cisco packet tracer. I think this one. You go and download packet tracer. You go here. Explore. Oh, let me see. For those who are Snap downloader, you log in into your account and you download the latest version there. I think it will allow you to download the latest version from there. Okay, let me see. Okay, download them. Some participation on packet tracer already.
Yeah, in that way, one green I was just playing around Angu. I think you were past 7. You want to go Dragon packet tracer. I hate it wrong, but I'm not thinking I got to update it.
Okay. Even I'm so used to the previous platform and GetPub. This one is new as well to me. I think I also need to learn with GitHub, but it's somewhere there. So you need to explore.
No,
Certified.
actually, you actually have to attempt to enroll per course actually packet tracer.
Oh,
Can
yeah.
you on a link like Pasiba?
If you enroll in any no any module noda packet tracer rinenge rine link rinokupa to download
That's new.
course ri download packet tracer setup it.
Okay, thank you very much. Yeah, that's new to me. I think the previous platform there was just but there was somewhere you could directly go to download. This is a new platform. I think it started was it September? And we had a class in one since. Right. So enroll classes or packet tracer, go download packet tracer, just browse through. I think we don't have much time. You go go through packet tracer. That said, let's move to lesson of the day. Let me see. Lesson of the day. I'm hoping a couple of you have already browsed through chapter 1. I'll be moving very quick because we also need to do some questions. Networking today. Networking. What is networking? Let's start there. And why are you doing this? The world we are living today, it's networks everywhere. There was someone who was saying it seems 2019 COVID exposed the need of networks in our day-to-day. I think outside Zim, outside Africa, most African countries, we were not that connected to the internet, which is the biggest network. We were not making use of those networks. But in COVID, we were restricted to our homes, but we still needed to work. What happened? People were working online, even on our WhatsApp, people were communicating online. That is networking, business. People were doing business online, learning. Since we are doing this online, I think before COVID, this was not very common. Even myself, I was very fortunate. I became a trainer 2000, I think 2019, 20 as well. And we were forced to do lessons online, to do lectures online. That's why to this day I even prefer online. I think it's a bit effective. You don't have to be on campus, you don't have to be in a classroom to to learn from wherever you are. Right. So what is facilitating all those things? It's a network connecting. What is connecting all the doors? What is connecting you and me at this point? That is what we call a network. Question, guys, for self-access, you can also download the app. It's easy to use and access studying materials. Thank you very much. I never use their app. Where is it? Google Play? Or for iPhone. What is that? I've never used their app, but thank you very much. As you say, app is very useful. Right. So I was talking about my networks. Everything we do, almost everything, is easy. We have our security being connected to the internet. Unokwanisa kuona namba yako from wherever you are. Monitor monitor your house. You can talk to your fridge via the internet. You can talk to your car via the internet. We have motikari dziri kufamba dzega. Autonomous vehicles. Is that it? Yes. We have motikari dziri kufamba dzega. How is that happening? It's because of my networks. So everything with respect to tech
In this video, you'll download and install Cisco Packet Tracer.
okay.
Cisco Packet Tracer
So
is free
everything
and available on the website of www.netacad.com.
linked to my networks. So it's very important. If you want to venture into tech, you start by understanding how my networks work. Because at some point, you're definitely going to cross paths NEMA networks. So this is the reason why we're having this course the CCNA, which is basically networking, but it can branch off and be a foundation. IT, network security, you will need to secure our information. We have cyber security, different types of security there. We have cloud computing, which are the trends currently zero cloud computing, everything stemming off from understanding what network is she and how does it function. Right, going to lecture here we're going to discuss the advances in modern technology, how network affect our lives, network components, topologies, types of networks that we have, internet connections, we have reliable networks, what makes a reliable network. And then we discuss trends, security, and career-wise, where do you go from here? So basically, that is what chapter 1 is. Right, networking affecting our lives. I think I've already gone through how networks affect our lives. Business, education, entertainment, streaming. We stream everything. Myself, okay? I stream everything. Football, everything streaming. Gaming through the internet. So it definitely affects our lives because almost everything that we do with respect to tech, it involves a network. No boundaries. I can communicate from here in Monarch, UK. It's possible. There's probably someone from the UK I don't class him. It wouldn't be possible without my networks. This is how networks are connecting us without my boundaries. Small stuff. Network components. What makes up a network? My components a network starting point. We have my devices at Rushandisa. My devices why announce my host. Technical term. Announce my host. It can either be a client or a server. Connectivity client is someone that needs, it's a device that needs information, the client. So in this example, since I'm the one talking, giving the information, you are the clients and your devices are the clients. But, not but at the moment, right? Then we have the server, ndo group information. So as we speak, need to act as a server because I'm the one giving that information. So in communication, in networking in general, you have two end devices communicating. One will be a client, the other one will be a server. If you Google something, if I go and Google something, what am I doing? I'm a client and I request information from a Google server. So who is Silence Madondo? If I Google that, the Google server, the applications that are on the web services, go and search for information per Google server, who is Silence Madondo. Server runs the information, who is Silence Madondo. So communication here in networking, that's the starting point. We have a client, we have a server, right? My types of my servers, as you can see, we have my email servers, web servers, file servers, small. No need to worry about that. My tabs, networks, we have what we call a peer-to-peer, which is a very common one. Yatinoshandisa especially kana uchisendera someone an easy example. If you want to send using if you send something using Bluetooth, that's a peer-to-peer network. Unokwanisa send. Is it? Yes. Unokwanisa sender, my phone can act as a client, it can also act as a server. Kana ndichisendera munhu, it means I'm acting as a server. If I'm receiving, it means I'm acting as a receiver. That is a peer-to-peer network. If we have two PCs in a network, by definition, a network is an interconnection of multiple devices, two or more devices. So if I have two phones, I already have a network. If I have two computers, for example, in this diagram, two computers, that's a network. All right? If I have 1 billion devices, that's a network. The internet is the largest network that we have, and it has, I don't know, billions of devices that are interconnected, making up a network. So peer-to-peer network is just a network where a device can act as a client and as a server at the same time. We have other types of networks where a server is a server. It does not need to act as a client, and a client is only a client and acts only as a client. So a peer-to-peer, you definitely see one of these questions from my exams saying, what is a peer-to-peer network? And by definition, it just means a client, a device can act as a client and as a server as well. Advantages, disadvantages, that's for you to study. All right, my end devices, we've already gone through that. Where the message originates and where the message terminates, where it is received. Do not my end devices. My examples in my end devices, I have my laptop here, you have your phones there, you have your laptops there. Do not my end devices. We are talking about components that makes up a network. So tadila my end devices, my PCs. We also have my intermediary devices. My intermediary devices, these are devices that interconnects the end devices. Examples, we have a switch, which is the most basic intermediary device. So a switch, how does it work? Right, I can write. This is a switch. This is a symbol, a switch. You need to know my symbols. I think there is a slide, where there is emphasis on understanding my symbols are. So this is a switch. We want something like this. This is a switch. For my symbols, if you are designing, right, this is what a switch looks like. So how does a switch works? Ndokurukupa information this side. Do send out 3 my PCs. I distribute like this. So information over from this one medium, you distribute into 3 my PCs. That is what a switch does. So it is an intermediary device. It acts sort of as a middleman. I think intermediary. Distributing. That is what an intermediate device is. So that is what a switch is. If PC 1, 2, 3 are sending, information is in power on this one medium. And that is how a switch works. Right. Basic. Then we have a router. Almost the same thing. It almost works the same as the switch. But this one separates my networks. So if I have a router, if I have a PC1 and a PC2, these are 2 PCs in 2 different networks. PC1 and 2 PCs in 2 different networks. The router acting as an intermediate device between this network and this network there. That's a router for you, intermediate device. We have my firewalls, security. So once I say a firewall here, what's the symbol for a firewall? It's also like this. Once I say a firewall here, it means information is up. In firewall. Most importantly, information in firewall so that it is secured. Can I read information in offer security risk to our network? It gets blocked. I pin them network. That's another intermediary device. So for my components my end devices, my intermediary devices, they are different. My end devices, they send or they receive the information. My intermediate device, they interconnect. So in between my end devices, Edu, we have all those intermediate devices making up what we call a network. My types, my components. Then lastly, the network media. The network media is the vehicle that transmits the information that we want to send. So from this end, I have my end device, my laptop. What I am lecturing is being transmitted. It's moving. That information is moving to begin through the air, right? Because I'm using Econet Yamasiwa. That's wireless connection. Through the air, you pick up a booster Yamasiwa. Then you have a fiber. You have a booster near you. You have a wirelessly per computer kana phone. The vehicle which is transmitting information from where I'm standing, media, network media. And we have different types of media. We have wireless, we have wired. For wired, you can see it in a copper. And a copper wire, can connect an Ethernet cable for my PCs in mukati macho. That might have been a white cable or a blue. Mukati macho mune to wire to get something like this. Where's my case? Let me see. To wired code, it makes up what we call laser. All right. Wood, wired. That is copper. I think the most common you will see. But for my physical sessions, we have a chance to even make our own cables, our own Ethernet cables, terminating them RJ45. Those are the copper. It's a medium, it's a vehicle which transmits our information. We have fiber. I'm sure you've heard of it. It transmits our information using light. We have wireless. Right? One of the examples, Yamasiwa Wi-Fi. If you're connected to a hotspot, information is being transmitted wirelessly. It's very important to know. So all my components at that time, this is what basically makes up what we call a network. Right. Representations and topologies. One, you need to know to my symbols. When you are designing, it will be very important. It's sort of a standard. Mchaita engineer, I hate to say this because everyone won't be an engineer. How do I put it? Mchaita professionals in IT. Mchaita my network administrators, mchaita cybersecurity specialists, whatever that is. If you're going to be my network engineers, you're going to be designing my networks. And if you're going to be designing my networks, I think there needs to be a standard. Like my architects, I'm sure my architects, Kadoka or not my architects, but my urban planners, designers. My planners, I'm sure they're not architects. I recently got a plan. Wanangazira plans is machine. That's my ability there. No, my architects. I need a response from someone who knows. Wananyora plan Zimba. Wananzanashi.
I think ndotofunga kuti ndo maarchitects acho aya because the blue anoita technical drawing edzimba echichi they should be architects.
Inakaita yangu asi architect. But I think my architects, they also do that. But I doubt. My planners or something like that, urban planners. But let me say this. You are my architects. I'm sure I can actually draw a door. I've seen their door ring right or something like this. Kanamanga plan. That is a standard. You can draw a door is now there. No one will know that is a door. Or a building that will not know that is a door. So there are certain symbols that that you need to learn and understand, depending on the type of technology, the type of equipment you are using. Probably my symbols that of Cisco, they'll be different from my symbols that Huawei, because that is a different company with a different infrastructure. So for Cisco, you need to know to symbol arc. That is a desktop, that is a PC. All right. switch one this route. So that no designer, we don't have to ask the chief because we know. So that is network representation. Now, if we talk of topologies, it's how a network is set up. Two type of topologies that we have. How many minutes do I have? 6. Two type of topologies that we have: the physical and the logical. So when you're designing a network, you need to know the physical topology. Where are the devices located? Basically, that is what the physical topology is. So you have a building. You have a building in floor 1, floor 2, floor 3. You are tasked to design a network. You go to every floor, it's connected. Every device in every floor is connected. I'll give you an example: a joiner. That is a very huge building. There is an engineer who is responsible for designing that network so that everything is interconnected. Everyone is connected to the internet, right? That designer, pakatangira the app, knowing kuti first floor makaita sei, mune marooms mangani, so maseva angu ndichamaisa maroom api, marouters angu ndichamaisa marooms api, maswitch angu ndichamaisa marooms api, ndichapinda floor number 2, where am I going to locate all my devices? In the room yandiri ndichaisa a rack, maswitch angu anenge ari murack nambani. That is very important kana uchidesign a network, so that panozoya tichidzoka kubuilding, panozoya builder chake kungoziva kuti ndichaisa chidhina up foundation ndichachera neup because munhu anenge akatarisa plan. Kunoko, I'm sure it's probably a technician, I don't know, it's probably a technician, the network admin or similar from there. But vachaenda kumberi networking, your job will be designing. Ndimi chaita architects designing kuti network ichabuda yakadai, then koyo vamwe vanovaka, they set up and install your network. So in the physical topology, showing where the devices are located. Then we have the logical topology. It shows us, for example, my ports. For devices edu, we have what we call my ports. Ngataisa laptop yangu, I can see my ports. Pandru is a USB. Dine port ndinoisa Ethernet LAN yangu. Dine ma ports anaiswa HDMI. Ma hose, maburi anenge ari pama devices edu. Those are ports. My devices, my routers, my switch. If you've seen a switch or a router, inenge ine mahose anenge anayo, maburi anenge anayo. Those are what we call my ports. My ports and my numbers, they are numbered. Kuti report USB, report HDMI, report fast Ethernet, report giga, serial port, console port. So the logical topology locates my ports kuti report rinonzi, right? That's one. The logical topology also shows my identifiers in my devices. So in a network, every device is an identifier. We have two types of identifiers that we'll learn at the beginning: the MAC address and the IP address. Panapa, we can see your IP address here, the network IP address, right? Number here, that is an identifier of a network. Then every device area, address here, which is unique. Meaning in a network, no one in address yakadaro. That's how we identify my addresses. Can I send a message from PCA? Let's say I have a switch. Didn't send a message from A. Did send a B. They send a message yangu. Inofana kwenda kuna B uko, because I'm using my unique identifier. So I address what I want to send my message to B. But how are you identifying B? It's either you're identifying it using a MAC address or an IP address. And my addresses, the while they have to be represented or shown in a topology. And that's how we develop yet not a logical topology. So the same buildings that we have, clear, right? So the same design that we have, panel in physical, showing my room numbers, my rack, shelf, etc., etc. My floors, if you can go there, it's the same thing. But here we are showing my addresses, my port numbers. This is the port number, G01, All right, so that's the difference between two types of topologies that it will be very important defining those two topologies. You definitely get a question, vunzo ukuthi logical topology chi, physical topology chi. Types of networks. My networks, we have my small networks, we have my huge networks. We have my networks, which allows us to communicate, share information in a confined location, very small, in our homes. Unokwanisa set a network where you can share information just in your homes. Mukaita Bluetooth can, or send on Bluetooth are more than 200 meters away, I think. You cannot do that. Signal, right? That is a very small network. So my home networks, they are very small by size. Then we have my big networks. For example, the one I'm using to communicate with you, that's a very huge network. What that we call a wide area network, right? That's the internet. So we have my small networks, we have my large networks. Before I go to the next one, I think I have less than 1 minute left there. So the trick is, this session is going to end. I start another one soon after, and you use the same link to join. You join again. We have one last session so that we can finish. I think let me end it and speed this up because past a minute up.